79 gigabytes, and the command that measures it says 0. One letter. DU was measuring the symlink, 17 bytes, instead of following it. 79 gigs, sitting on an 11 terabyte disk that cost $40, and Claude has absolutely no idea. One line of terminal did that. It's a trick from 1983. This tool has a setting that's supposed to do exactly this. It doesn't work, and why it doesn't is more interesting than the fix. There's also a second thing quietly eating your memory that nobody mentions. It's on a 30-day timer. I'll get to it. Two completely different walls here, and people mesh them together constantly. Wall 1 is context, a fixed window every session. Memory tools inject your past into it. That injection costs tokens, and it competes with your actual task for the same budget. Wall 2 is disk. Everything the tool captures has to physically live somewhere. Here's what people get backwards. A bigger archive does not cost more tokens because a good memory tool doesn't inject the archive, it retrieves. Top handful of relevant chunks, nothing else. So the archive can be 100 gigabytes and your per session cost stays flat. The only real limit is how much disk you're willing to give it. Disk, not tokens. That's a $40 problem. And the 30-day thing. By default, Claude Code deletes your session transcripts after 30 days, not archives, unlinks, no trash, no undo. For most work, that's housekeeping. For research work, that context is the artifact. I'm not the only person who noticed. There are 4 open issues on the Claude Code repo asking to choose where this stuff gets stored. One of them has the word hard-coded in the official title. One of them is someone reporting 537 gigabytes from a single session. If you've ever lost a session you wanted back, tell me in the comments how bad it got. I want to see the worst one. Let me show you what's actually in there, because the split is not what people expect. The SQLite database, every session, every observation, 24 gigs, a 3 gig write-ahead log that hasn't been checkpointed, and the vector index for semantic search, 53 gigs. Embeddings are dense and they compound. Worth knowing that vector store is itself a SQLite file plus a binary graph. 2 databases in here, not one. That matters in about 6 minutes. And the raw transcripts, the sleeper hog everyone forgets, not in here at all. They're in your .claude projects folder, 2200 JSON files. Same trick works on them separately. Oh, sort-h is GNU. If you're on a Mac and that errors, drop the -h. So, change the setting. ClaudeMem has one. The docs say it only works in development. The docs are out of date. The code reads it in production too. So why not just use it? Because I went looking, and exactly one file in that code base honors it. 24 others hard-code your home directory straight into the path. And the one that matters is the vector stores manager, line 31. A hard-coded string, which means if you set that config, the 24 gig database moves, and the 53 gig vector store stays exactly where it is, you'd move a third of the problem and split your install in half. There's a lovely bit of recursion in it too. The code reads its settings file from the default location. The setting that tells it where to put its data lives inside the folder you're trying to move. It cannot relocate the file containing the instruction to relocate. 2 options: fork the tool and rebuild it every update, or lie to it at a layer it can't see. One place, once, and all 25 code paths follow you. We're going to lie to it. Quick refresher, because most people half remember this. On a Unix file system, a file name is not the file. The data lives in a structure called an inode. The bytes, the permissions, the timestamps. A file name is just an entry in a directory that points at an inode number. Think of it as a name on a mailbox. The name isn't the mail. So names and data are separate things, and 2 tricks fall out of that. A hard link is a second name pointing at the same inode. 2 names on one mailbox, genuinely equal, there's no original. Watch the inode numbers, identical. Delete one name and the data survives because the inode still has a reference. Delete the last name and it's gone. But a hard link can't cross a file system. An inode number only means something inside one file system. So a hard link from your SSD to your hard drive is not a thing that can exist. And before someone asks, no, you can't hard link a directory, the kernel refuses outright. Two names for one directory would let you build a loop in the tree. Every tool that walks a file system would spin forever, and dot dot would stop having one right answer. Which is exactly why symbolic links were invented in 1983 to fix that limitation. A symlink is a different animal. It's a tiny file whose entire contents are a path, a string. When anything opens it, the kernel reads that string and redirects. It's not a second name on the mailbox, it's a forwarding address to another city. And because it's just a path, it doesn't care about file stems at all. Another drive, another partition, a path that doesn't exist yet. There's the arrow. That arrow is the whole video. The redirect happens in the kernel, below the application. Your program calls open. The kernel resolves the link. The program gets a file handle and nothing in it says where it came from. To be precise, because someone will absolutely say this in the comments, the kernel doesn't hide symlinks. Resolving them is just the default. A program can ask, lstat tells it the name is a link, read link hands it the target, open with the no follow flag refuses. It just has to want to know. So the honest version, a symlink is invisible to any program that doesn't specifically ask. Security sensitive code asks. An app opening its own config file does not. That's why this works on software that hard-coded its own path. I know, file system theory. Stay with me. Now let's point the arrow at a hard drive. Every command is in the description, copy paste ready with timestamps. If this next part is what you came for, it starts now. Not one process. Claude Mem runs a supervisor, a worker, an MCP server, and a separate process for the vector store. The worker's on port 37777. The vector processes aren't on any port, so check only that port and you'll get an all clear while 53 gigs of index is still open. Moving a database out from under a live process is how you get corruption. And use the listen flag. Without it, you'll also kill the clients on the other end of the connection. Dash A is archive, recursive, and it preserves permissions, timestamps, ownership, and copies symlinks as symlinks. Dash H preserves hard links, so two names on one inode arrive as two names on one inode. Capital A and X are ACLs and extended attributes. And the trailing slashes. Source with a slash means the contents of source. Without one, it means the directory itself, which lands your data a level deeper than you wanted. Both slashes, every time. While that runs, this is 79 gigabytes of everything Claude has ever learned about my code, moving onto a drive that costs less than 1 month of Claude Pro. Copy, don't move. If this goes wrong, we want the original untouched. And in about 90 seconds, I'm going to show you the exact way this goes wrong, because I hid it. Rename it. Don't delete it. We delete it a week from now, once we are sure. Not today. That's it. That's the whole trick. That's the video. Here's the one I promised. If that path still exists when you run that line, the link doesn't replace it. It gets created inside it. Exit code 0. No warning. You now have a symlink buried a level down, doing nothing. And every check you run afterwards looks wrong for reasons that make no sense. That's why step 4 comes before step 5. Order matters. Claude Mem doesn't ship slash commands. It skills and an MCP server. But the worker exposes its own stats endpoint, and this is the better shot anyway. Look at the path it reports. Home folder, 24 gigabytes. The application is telling you in its own words that its database is in my home directory, and every one of those bytes is on the spinning disk. That's the trick working. Session and observation counts should match what you wrote down before. If they're zero, stop and roll back. Rollback is 90 seconds. RM on a symlink deletes the link, not the target. That's why this is safe to try. And the one that will genuinely bite someone. Do not put a trailing slash on it. Without the slash, you remove a 17-byte link. With it, one character. It follows the link and deletes everything on the other side. Exit code 0. And here's the evil part. The symlink survives, so every check in this video still passes. ls shows the arrow, read link prints the right path, and the archive is gone. No trailing slash ever. On a symlink, that slash means go through it. Windows, same idea, needs administrator, unless you're on PowerShell 7 with developer mode on, which can do it unelevated. Mac, your mount is under volumes, and stock rsync on Sequoia has no -a and no -x. It's -ahe there. Internal hard drive, external USB, second SSD. All fine. ANAS over SMB or NFS. Don't. Escalate depends on the file system's locking being correct, and advisory locking is buggy or missing on a lot of network file systems. Their docs name NFS specifically. If locking is broken and two processes touch the database at once, corruption might result. It's not a guarantee of failure. It's the loss of the guarantee of success. And it's worse here. This store is in write-ahead log mode, which needs shared memory, exactly the thing that doesn't work across a network mount. And there are two SQLite databases in that directory. Two chances to lose. Spinning disks are slow, and search is random reads, the exact thing a mechanical drive is worst at. You'll feel it on recall. So here's the smarter version. Selective symlinking. But look at the numbers first. Logs are 172 megabytes out of 79 gigs. Moving logs freeze nothing. 53 of those gigs are the vector store. That's the thing to move. The database is 24 gigs, but it's the hot one. Every lookup hits it first. So the database stays on the SSD and the vector store goes to the hard drive. And this is the satisfying part. Remember that hard-coded vector store path, line 31? That's the one thing the config setting can never move. But it's a path, and a symlink beats a path. Hot data fast, cold data cheap. That's tiered storage. What every database on Earth does, you've just done it by hand on a path the vendor hard-coded. If the drive isn't mounted, the link points at nothing, and Claude Mem handles that cleanly. It errors and stops. The sneaky case is when your mount point exists but the drive doesn't, and something creates that path anyway. Now the link is valid and it points at an empty folder on your SSD. And the obvious guard misses it because a directory does exist, it's just the wrong one. Check for the database, not the folder. The takeaway isn't Claude Mem, it's that a file name and a file are different things, and every piece of software that hardcodes a path is quietly assuming you don't know that. Docker images, Steam libraries, Olama models, browser caches, node modules, same command, same afternoon. You learned this in a systems class and never used it. Go use it. That's the video. Thanks for watching. You thought I forgot. Does this actually slow Claude down? I timed it. Cold recall went from 0.4 seconds to 1.9. Warm, you can't feel it. Worth 79 gigabytes of SSD back. For me, obviously. On a laptop with one drive, skip it and turn your injection count down instead. Next week, cutting the token cost of that injection. Subscribe so you get it.